Okay guys, welcome back. So what we're going to do today is I've had quite a number of people ask me to redo all the old dog calculations. Now, while these formulas are no longer in there, a lot of RTOs are still using them as part of their unit of competency, and so you can understand how to work out what chains are actually good for. Now, in the real world, I know we're going to look at the lift charts, etc. So if you want to understand them, you can go back to my previous video on understanding the sling charts. But we're going to cover how they work out the calculations to work out what those chains are actually good for. All right. So what we'll do, we'll start off with the basics. So what we're going to do to start off with is we're going to have a look at a set of chains. Now, a set of chains, the formula is pretty simple. Okay. So the formula we're going to use is the diameter times the diameter times the safety factor. All right. Now, the thing about this is all you need to do is remember the formula, because once you've got the formula down, then all you're ever going to need to do is write the numbers underneath, jump on a calculator, and come up with an answer. All right. So using this formula, we'll just say we've got a leg of a 10mm chain. Now, with 10mm chain, all we're going to do, put the numbers underneath. And it's 10 times 10 times. Now, the safety factor, all right, the way you work that out is the safety factor, if we're using 80 grade chain, it'll be 80 times 0.4, okay? If it's 100 grade, you're going to use 100 times 0.4, all right? So if we have a look up here, we'll say 80 grade and 100 grade, all right? So 80 grade, 80 times 0.4 is going to give you a 32. All right. So the safety factor we're going to use for 80 grade is 32. For 100 grade, it's going to be 40. All right. So if we're using 10mm 80 grade chain, 10 times 10 times 32 equals 3,200. Okay. So now that's how much you can lift on a single leg of 10mm chains on 80 grade. Now, if you're not sure what grade it is, okay, you can look on the tag or on the link of the chain. So 80 grade is generally got a T for the 80 grade chain, or if it's 100 grade, you'll have a V there for the 100 grade. Okay, so that's a single leg of a 80 grade chain, 10mm. If it was 100 grade, all right, we can just do the same thing again. D times SF. So the diameter is going to remain the same as 10 times 10 times, now the safety factor now, 100 grade, so 100 times 0.4 is 40. So it's now going to be 40, which is going to equal 4,000 kilos. All right. So it's as simple as that. If you just remember that formula, diameter times the safety factor, it's going to tell you what it's good for. And as you can see there, 100 grade can lift more than the 80 grade. And it's also lighter as well. So the 100 grade is always a much better chain to use. And they are becoming a lot more popular in the industry now compared to what they were. They were sort of overpriced a number of years back, but they're coming down in price and you're starting to see a lot more of the 100 grade out there. All right, so it's much better, reduces manual handling, and you can also lift more with them as well. All right, now the next thing is, now we're typically not going to use just a single leg. We're more than likely going to use 2, 3, 4 legs to lift a load. All right, so what we do in that instance, okay, now you can't just say one leg's good for 3,200, so if you've got 2, you're going to be good for 6,400. It doesn't quite work that way. When you've got the 2 chains, you're going to have an angle involved there as well. All right, so this is where we have to look at our angle factors. Now, our angle factors, all right, so you've got 120, which is always going to be your maximum angle. Okay? Then we'll use 90. We'll put a 60 in there as well. We'll go for a 45 and we'll go for a 30. So we'll just name a few angles there. All right. Now, with the angles, all right, so 120, that's your maximum angle. And if you've got two legs at 120, you can only lift as good, the same as you can on a single leg due to the angle factor involved. All right, so the angle factor for a 120 is 1. For 90 degrees, it's going to be 1.41. 60 degrees is 1.73. 45 is 1.84. And 30 is 1.93. Okay. Now, luckily you don't have to remember all of them in the new assessments, but it's always handy to remember the 60, the 90 and the 120. Okay, now how do we use those? If we've got a single leg here, that's good for 3,200, all right? To get two of them, if you're at, let's say, 60 degrees, we'll just get rid of that bit. All right. So all you need to do now is you've got your original formula, D times SF. Now, if there's an angle involved, because you've got more than one leg, you just chuck on the end there, times angle factor. Okay? So all we do now is write the numbers under again. So you've still got 10 times 32, using the 80 grade. And then just chuck on the end the angle factor. Right, let's say we're at 60 degrees, okay, so the angle factor is now going to be 1.73. So we'll chuck that in there as well. All right, and then you've just come up with an answer. Okay, so bring out the old trusty calculator. Now, I do know off the top of my head, it's going to be somewhere around 5,500 because on 10mm chains, that's what the tag's going to tell you you're good for. Okay. So we've got 10 times 10 times 32 times 1.73 equals 5,536. Okay, so 5,536 kilos. Okay, so quite simply, that's how you work it out if you've got two legs. Okay, but what if you've got three legs or four legs? Well, you see, what you've got to remember is you're only ever going to count two legs as carrying the load. So whether you've got three or four legs, you still count it as though it's only the two legs. All right, so it doesn't matter if you've got three or four legs, it's still going to be maximum load you can lift. Doing it this way, you're going to work it out as 5,536. But remember to always look on the tag, because if you look on the tag on 10mm chains, it's going to tell you it's good for 5,500. All right. Don't go over that. Don't say, oh, but there's a safety factor. Don't worry about safety factors. Just stick to what the tag says. Don't go over it. Okay. Now, what if we need to choke that load? Now, every time you choke a load, it's going to have an effect on the sling. Okay? So, we'll come back to here. All right. So, what you've got to remember, your reeving factors. So, if you're using chains, the only reeving factor you've really got to worry about is 0.75. All right, so the reeving factor for chains is 0.75. Okay, now that doesn't matter if it's a square load or a round load. It's going to be the same if you're using chains. When we use flexible steel wire rope, different story, because if you wrap flexible steel wire rope around a square load, then your reeving factor is going to be 0.5 because it actually halves what they're actually good for. All right, so what do we do here? All we need to do is chuck that on the end of the formula. All right, so times reeving factor. So reeving factor using chains is going to be 0.75. Okay, and let's have a look at what we come up with now. So we've got 10 times 10 times 32 times 1.73 times 0.75 equals 4,152 kilos. 4,152 kilos. Okay. So it doesn't matter how it's slung up. If you've got a single leg, you can work it out that you're going to lift 3,200. If you've got an angle, chuck that on there as well. That'll give you the next answer. If it's choked, chuck the choking factor on there as well. But just remember, it's always a tag that you need to go back to in the long run, all right? But that explains to you just how exactly they work all that out. So if you look on the tag, from memory, 60 degrees and choke to 10 mil chains, pretty sure the tag's going to say 4.1 tonne. Okay, could be wrong, don't quote me on it, but I'm pretty sure. I don't have it set on me at the moment, but that's how you work it out. All right, so that's nice and simple. But if you're using flexible steel wire rope, all right, what you've got to do is, it's all the same formula, except when you're talking about the safety factor on flexible steel wire rope, it's going to be 8. Okay, so flexible steel wire rope is 8. So let's say we're going to use a 10 mil flexible steel wire rope. All right, let's get rid of that there. Same scenario. We've got 2 of them at 60 degrees, choked around a round load. All we do is we'll change that from a 32 to an 8. Okay? So 10 times 10 gives you 100, times 8 is 800, which tells you straight away that on a single leg of 10 mil flexible steel wire rope, you'd be able to lift 800 kilos. All right, let's keep going. So we've got 10 times 10 times 8 times 1.73 times 0.75 equals 1,038 kilos. So, okay, so using flexible steel wire rope, in the same configuration as we just used the chains. So with the chains we could lift just over 4.1 tonne. Flexible steel wire rope, just 1,038 kilos. Okay, so you can see there is a big difference between the capacity you can lift with either flexible steel wire rope or with chains. Also keep in mind, using flexible steel wire rope, if you are choking it around a square load, that reeving factor will change to 0.5. Okay, so that's basically how you understand what the capacity of each crane, of each lift equipment is. Okay, whether it be chains, whether it be flexible steel wire rope, it gives you an understanding of how they work out what their capacities are. Okay, now what about if we've got a load and we want to figure out, okay, what size chains are we going to need to lift the load? All right, so instead of working out how much you can lift with the chains, we're just basically doing it in reverse. So let's go back to here. Okay, so let's say we have a load and that load is going to weigh, let's say, 8 tonne. Okay, so the formula we're going to use is we use the square root of the load divided by the safety factor. Okay, so if we want to work out what size 80 grade chain we need to lift that load, what we need to do is we write the formula down. Then what we do is underneath we write down the figures. So square root of the load, what did I say, 8 tonne, so 8,000 kilos, divided by the safety factor for the 80 grade chain is going to be 32. Okay, so we'll jump on the calculator. You go 8,000 divided by 32 equals 250. So that equals 250. Now don't forget we've got this little square root sign. Alright, so what we need to do there is now hit the square root button, and that's going to tell us we need 15.8 mil. Alright. Alright. Now we're not going to find a 15.8 millimeter flexible steel wire rope, and you can't go down below it. All right, so always just round it up to the next whole number. All right, never round down, always round up, because that's the minimum. You don't want to go below it. All right, so if you round it up, it's going to be 16 millimeters. Okay, so if we had a single chain to lift an 8-ton load, you would need a 16 millimeter chain in order to do that. Okay, now with the reeving factors and the angle factors, same as when you're working out the how much you can lift with the chain, you just add them onto the end. Except in this instance, we started with dividing and we're going to keep dividing as we go. All right, so let's put the whole lot up. Let's say we've got 62, we need 2 sets at 60 degrees, 2 legs at 60 degrees, choked around a load. All right, so that means we're going to have both an angle factor and a reeving factor. All right, so let's get rid of this bit down the bottom here. All right, so if our angle factor was 60, back to 1.73, and our reeving factor around a round load was 0.75. All right, now all you need to do this sum first. Okay, so let's cancel that out and go back. So 8,000, now this time we're dividing by 32 divided by 1.73 divided by 0.75 equals 192. Okay, now that we've got that answer, we just, because we've still got the square root sign here because we haven't done anything with that yet, so now we hit the square root button, which gives us 13.8 mil. Right, and we round that up to 14 millimeters. All right. So that tells you the minimum we're going to need. So minimum we're going to need 14 millimeters. And in case you don't know, you can't get 14 millimeter chains. So essentially you're going to be going up to 16 mil. Chains only come in specific sizes. Off the top of my head, you can get 6, 7, 8, 10, 13, 16, 19, 20, 22, 26, 32, and I have seen some 36s as well. All right, so you're just going to go up to the next available one. Okay, always go up, never go down, because if that's the minimum you need, so you can't say, oh, 13 mils the closest, because you'll be overloading them. All right, so that's just a quick and easy explanation of how you're going to figure out what size chains are required to lift a load. Don't forget, go back to the sling charts, all right, and the sling tags. Quickest and easiest way to work it out is by looking at them. But that just gives a quick explanation of how you do it. All right, now another thing I'm going to cover while I'm here today is how do you work out the weight of a pipe, okay? It's one that a lot of people tend to get stuck on at times. All right, so what we'll do is we'll get rid of all of this. All right, and we'll do a pipe. All right, so we've got a pipe here. Okay, hope no one's marking me on my drawing. All right, let's say we have an outside diameter of 1.2 meters and an inside diameter of 1 meter. Let's say it's made out of concrete. Okay, and let's say it's 10 meters long. All right, now to work out the weight of it, first we need to work out the volume. All right, now when we work out the volume, we go back to a formula you would have learned back in high school, which seems like decades ago, and it was decades ago. All right, but we go back to the old formula of pi times radius times length. All right, now do yourselves a favour, if you're working one of these out, write that formula down twice, just leave a gap in between it for some writing. All right, so pi times radius times length. Okay, now why do I write it down twice? Well, when you do the outside diameter, it's going to give you the volume of a whole solid cylinder. All right, so then we need to find out what the empty bit is in the middle and take that out. So we need to work it out twice. So using the outside and then using the inside and then taking that out, and what's left is the volume of just the pipe itself. Okay, so the pi, if you don't remember what pi is, it's always going to remain constant at 3.14. Okay, so pi 3.14 times. Now, it's times the radius. Now, we know the outside diameter and we know the inside diameter. So, but we need to use the radius, not the diameter. So, when you look at a circle, okay, the diameter is from one side to the other. Okay, whereas the radius is from the center of the circle to the outside. So the radius is half of the diameter. Okay, so if our outside diameter is 1.2, that means the outside radius is half of that, which is 0.6. Okay, so 3.14 times 0.6 times 0.6 times, and the length 10. All right. Now, what I tend to do typically is, I won't work it out yet, I'll just write all the figures in that I need. All right. So you do once with the outside diameter, and then we do it again with the inside diameter. All right, so the inside diameter is 1 meter, which means our radius is going to be 0.5. Okay, so 3.14 times radius, this time 0.5, times 0.5 times the length, which is 10. All right, now we'll just work both of them out and see what we come up with. Okay, so got 3.14 times 0.6 times 0.6 times 10 equals 11. I don't trust it. I'm just going to double check. Now, it's always a good idea whenever you're doing this, always double check your calculator. It's very easy to press the wrong button. All right, so 3.14 times 0.6 times 0.6 times 10 equals 11.304. Okay, so 11.304. Okay, and that is meters cubed. All right, because that is the volume of one whole solid pipe. All right, so what we want to do is we want to find out what the middle bit is, and we want to take that out because that's hollow. That isn't actually in there. So we'll go back to here, we'll go 3.14 times 0.5 times 0.5 times 10 equals 7.85. 5 meters cubed. Okay, so as you can see, if you write it down twice, just put the figures underneath them, then just go through, run it through on a calculator. All right, so what you need to do now, you've got this figure, just take that figure away from it. All right, so if we've got 11.304 minus 7.85 equals 3.454. 3.454 meters cubed. All right. So now we know what the volume is of just this concrete that's in the pipe. we've taken out that middle bit, so we don't need to worry about that. Now to work out the weight, all we need to do is multiply that by, because concrete weighs 2,400 kilos per cubic metre, all we need to do is multiply this by 2,400 kilos, and that should give us our answer. All right, so if we go times 2,400, okay, so times 2,400 equals, so we end up with 8,289.6 tonne. Sorry, my mistake. Kilos. So we got 8,289.6 kilos. Now, if you wanted to round that up to the nearest tonne, all you would do is go up to 9 tonne. Okay, so basically a lot of people do get confused on this, but if you keep it simple and you set it out like this, it makes it quite easy. You write the formula down twice, then you put the numbers underneath it. Alright, multiply them both out, then you get that, take away that, equals that, which gives you the volume. Then just, if it's made out of concrete, you multiply by 2,400, and that will give you your total weight. So you end up with 8,289.6. Okay, now that is one that a lot of people do seem to struggle with a little bit, but if you set it out like that, it's nice and simple. Just remember, every time you write down this, if you're working out a pi, every time you write down this pi times r times r times l, write it down twice, all right? One for the outside, one for the inside, and then it just flows through from there. Okay. All right. Okay, so I hope that helps you understand it a little bit better. And if you do have any questions on it, don't forget to leave a question down in the comments, and I will try and get back to it. I am kept rather busy at the moment, so I will try and get back to it as soon as I can. So any questions at all, leave in the comments. If there's anything you want me to do a video on as well, just put that in the comments as well. All right, so thanks for your time and for listening, and see you in the next video. Thanks.